So find the values of k so that the function f is continuous at the indicated point in exercises 26 to 29. So these are the important problems for 4 marks. See, what are they given? F of x equal to k into cos x divided by pi minus 2x if x is not equal to pi by 2. 3 if x equal to pi by 2. So at x equal to pi by 2, the function is continuous function. So given that f of x is continuous at x is equal to pi by 2 here. So therefore, LHL is equal to RHL is equal to f of pi by 2. Okay. So LHL means limit x tends to pi by 2 minus f of x is equal to limit x tends to pi by 2 plus f of x is equal to f of pi by 2. Okay. So pi by 2 minus, so pi by 2 minus also will take k cos x this function only. So limit x tends to pi by 2 minus f of x is k cos x divided by pi minus 2x, which is equal to limit x tends to pi by 2 plus f of x also same, pi by 2 plus also will take this only, k cos x divided by pi minus 2x is equal to f of pi by 2. So pi by 2 is nothing but value of the function is equal to 3 will get here. So this can be written as limit x tends to pi by 2 minus. So here k into cos x can be written as sin 90 minus theta here. So sin 90 minus theta divided by. So here also you can take 2 as common here. So what will get here? So this will become pi by 2 minus x will get here, which is equal to. So 2, if you multiply here also, 2 into this pi by 2. So 2 to get cancelled, pi minus 2 into x is 2x. So previous step only will get here. So here also limit x tends to pi by 2 plus, here also same you can take, cos can be written as sin 90 minus theta, sin pi by 2 minus x divided by, here also 2 you can take common, pi by 2 minus x, which is equal to 3 here. Okay, so now this k and 2 are constants, means we will take out. So k by 2 into limit. So this pi by 2 also send this side, x minus pi by 2 or pi by 2 tends to 0. So then it will become here k. So sin pi by 2 minus x divided by pi by 2 minus x is equal to, even here also limit. So k by 2 you can take out here. So limit, so pi by 2 minus x or x minus pi by 2 tends to 0. So here sin pi by 2 minus x divided by pi by 2 minus x, which is equal to 3 here. We know this value is limit x tends to 0 sin x by x is equal to 1 here. So k by 2 into 1 is equal to, here also k by 2 into 1 is equal to 3 you will get here. Take any two values. So k by 2 is equal to 3. So k is equal to 6 is the answer here. Okay, the value of k is equal to 6 here. Next 27th one. F of x equal to kx square if x is less than or equal to 2. X is greater than 2 means that is 3. The function is continuous at x equal to 2 here. So given that f of x is continuous at x equal to 2 here. So LHL equal to or HL is equal to f of 2 here. So LHL means limit x tends to 2 minus f of x is equal to limit x tends to 2 plus f of x is equal to f of 2 here. So 2 minus means less than 2 will take, that is nothing but kx square function. Limit x tends to 2 minus, so less than 2, the function is kx square is equal to 2 plus means we'll take here 3, which is equal to f of 2 function also k into 2 square will get it. So if you substitute here 2, k into 2 square is equal to 3 is equal to, this is 4k here. So 4k is equal to 3 is equal to 4k here. So take any two values here. So 4k is equal to 3. So k is equal to 3 by 4 is the answer here. Okay. 28th one also. F of x equal to kx plus 1 if x is less than or equal to pi, and cos x if x is greater than pi here. So is continuous at x equal to pi. So given that x is continuous at x equal to pi here. So LHL is equal to RHL is equal to f of pi. So LHL is limit x tends to pi minus f of x is equal to limit x tends to pi plus f of x is equal to f of pi here. So pi minus means less than pi, kx plus 1 will take here. Limit x tends to pi minus. So pi minus this function is kx plus 1 is equal to limit x tends to pi plus. So pi plus means greater than pi. So that we'll get here cos x is equal to f of pi means equal to pi, that is kx plus 1. So k into pi plus 1 will get here. So pi minus if you substitute here, k into pi plus 1 is equal to cos pi, which is equal to pi k plus 1 here. So we know that cos 180 degrees value is minus 1. So k pi plus 1. So we are taking these two values. So k pi plus 1 is equal to minus 1. K pi is equal to minus 1 plus 1 also send that side, minus 1 will get. So which is minus 2 here. So k is equal to minus 2 divided by pi is the required answer here. Okay. Next, 29th one. So here also f of x is equal to kx plus 1 if x is less than or equal to 5, 3x minus 5 if x is greater than 5. So is continuous at x equal to 5 here. Given that f is continuous at x equal to 5 here. So is continuous at x equal to 5 means same LHL equal to RHL is equal to f of 5 here. So LHL is limit x tends to 5 minus f of x is equal to limit x tends to 5 plus f of x is equal to f of 5 here. So 5 minus means less than 5. So limit x tends to 5 minus. So this is kx plus 1 is equal to limit x tends to 5 plus. So 5 plus means greater than 5. That is 3x minus 5 is equal to f of 5 is equal to 5 means k into 5 plus 1 will get here. Now, so we are taking this function. If you substitute here, 5k plus 1 is equal to here also 3 into 5 minus 5 is equal to here also 5k plus 1. So take any two. So 5k plus 1 is equal to 3 into 5 is 15 minus 5 is equal to 10 here. So 5k is equal to 10 minus 1 which is equal to 9. So k is equal to 9 by 5 is the answer here. Okay. Next 30. So this is also one of the important here. So find the values of a and b such that the function is defined by, so the function is f of x. So this is the continuous function. So continuous function means here the values they given in terms of 2 and 10 they given means the function is continuous at 2 and the function is continuous at 10 also. So given that f is continuous at x equal to 2 here. So 2 means limit x tends to 2 minus f of x is equal to limit x tends to 2 plus f of x is equal to f of 2 here. So 2 minus f of x is less than 2 means this one will take as 5 here, which is equal to 2 plus means greater than 2. So greater than 2 is this is the function. Ax plus b means wherever x is there will substitute 2. A2 plus b is equal to f of 2 means is equal to 5. So this function will get here. So 2a plus b is equal to 5 is the answer. This is one linear equation we got here. Again, the function is they given here. This is continuous at x equal to 10 here. So f is continuous at x is equal to 10 here. So limit x tends to 10 minus f of x is equal to limit x tends to 10 plus f of x is equal to f of 10. Okay. So limit x tends to 10 minus f of x. 10 minus means less than 10, that is ax plus b, which is equal to limit x tends to 10 plus. So 10 plus is greater than 10, that is 21 we will get, which is nothing but f of 10 also will get 21 only. So 10 if you substitute here, 10a plus b is equal to 21 here. So we are taking only two values here. This is equation 1 we are taking. This is equation number 2. So now equation 2 minus equation 1 if we will do equation 2 minus equation 1. So 10a plus b is equal to 21 here. 2a plus b is equal to 5 here. Do subtraction here. 21 minus 5 is 16. This will become minus minus minus. Plus b minus b will get cancelled. 10 minus 2 is 8a. So 8a is equal to 16. A is equal to 2 here. Okay. A value substitute in equation 1. So that is 2a plus b is equal to 5. So 2 into 2 plus b is equal to 5. So b is equal to 5 minus 4. So b is equal to 1 here. Therefore, the values of a is equal to 2 and b is equal to 1 is the answer here. Okay. Next 31st one. Show that the function defined by f of x is equal to cos of x square is the continuous function here. So this is in the form of g of h formula. So g of h formula means if you show that g and h both are continuous, then g into h is also a continuous function only here. Okay. So first what we are taking here, given that f is combination of g and h here. So here where g of x is nothing but cos x and h of x is nothing but x square here. So now we have to prove that both the g and h are continuous functions. We have to prove here. So g of x is equal to cos x. We know that cos x function is already continuous function only. Okay. So we know that cos x is continuous function. Okay. And h of x also we have to find out here. So h of x also x square we are getting here. So limit x tends to k, h of x is equal to limit x tends to k. H of x is nothing but x square. If you substitute k means you will get k square here. Even h of k also will get k square here. So therefore limit h tends to k, f of x is equal to f of k here. So h of x is continuous function. Okay. So we know f of x is continuous, sorry, g of x is continuous and h of x also continuous only. So g of x and h of x are continuous functions. Therefore, g into h also continuous function. So f of x is equal to g into h is nothing but g circuit h. So g of h is nothing but x square. G of x is cos x here. So cos of x square is the f of x here. So f of x is equal to cos of x square is a continuous function here. Okay. Next, 32nd one. Show that the function defined by f of x is equal to modulus of cos x is a continuous function here. Okay. First, we will arrange here. Here also, f is combination of g and h here. So here g of x is nothing but modulus x and h of x is nothing but cos x here. Okay. So f of x can be written as g circuit h. So which is nothing but g of h of x, which is equal to g of h of x is cos x. So it is in the form of g of x. So g of x is modulus x means modulus of cos x. So this is the function here. Now we are taking here the first part is g of x is modulus of x here. So g of x is equal to modulus of x we are taking here now. So modulus x means what we can write here. So one is minus x if x is less than 0, positive x only if x is greater than or equal to 0 here. Okay. So if k is any real number, k be a real number. So if it is a real number means total how many cases you will get here? Here also you will get here total 3 cases you will get here. If k is less than 0, so first one is case 1. Okay. If k is less than 0, so k is less than 0 means g of k is equal to how much you will get here. So less than 0 means we are getting minus x. So minus 0 means how much you will get here. So limit x tends to k minus f of x is equal to limit x tends to k minus x. So minus x is nothing but substitute here 0 will get here. Even limit function also g of k also will get here 0. So therefore g is continuous for all real numbers less than 0. Okay. The next one is second case is we'll take here if k is equal to 0. If k is equal to 0. So k equal to 0 means what you'll get here. The first one is g of 0 is equal to 0 is nothing but 0 only will get here. Yeah, equal to 0 means we'll get here 0 only. Next limit function LHL, it will take here limit x tends to 0 minus g of x is equal to limit x tends to 0 minus is nothing but minus x, finally will get 0. Even RHL also limit x tends to 0 plus g of x is equal to limit x tends to 0 plus g of x is plus x only. So here also will get 0 here. Therefore, LHL is equal to RHL is equal to g of 0 here. Therefore, g is continuous at k equal to 0 here. Case 3 also. So if k is greater than 0. So k is greater than 0 means what we'll get here? First one is g of k also equal to 0 only. And limit function, if we'll find out, limit x tends to 0. G of k is greater than also 0, we'll get finally 0 only. So g is continuous at k is equal to greater than 0 here. So now we can say that directly. So g is continuous function. G is continuous function. Okay, continuous function for all real numbers. Okay, so next one is h of x is equal to cos x. We know that cos x is also a continuous function. Okay? Is also continuous function. Therefore, f of x is equal to modulus of cos x is continuous function. Okay. Next one is examine that sin x is the sin of modulus x is the continuous function here. So even here also we'll take here f is the combination of g and h here. So here g of x is nothing but sin x g of x will get here modulus x and h of x is sin x will get here. Okay, so we have to prove that now these are the functions or continuous functions here. So the first one is f of x can be written as, so f of x is equal to h of g of x here. So h of g of x. So g of x is nothing but modulus x, h of modulus x. H of x is sin x form. So sin of modulus x will be. So first we'll take here g of x is equal to modulus x. So modulus x function is continuous function only. So modulus x is always continuous function. And h of x is equal to sin x is also continuous function. Okay, therefore f of x is equal to h of g of x is equal to h of g of x is modulus x, which is nothing but sin of modulus x, is continuous function here. Okay, next 34 also same, f of x equal to modulus x minus of modulus of x plus 1 here. See, f of x equal to modulus x of minus of modulus x plus 1. We know that modulus function also continuous only. Modulus of x plus 1 also continuous function only. So even their subtraction also is continuous function only. We'll get here. So g of x is equal to modulus x. You can take h of x is equal to modulus of x plus 1 will get. So therefore, g of x is continuous function. But because we have proved so many times, so modulus x is a continuous function. And h of x also continuous only. Okay. So therefore, their subtraction also g minus h is also continuous function. Therefore, f of x is equal to modulus x minus modulus of x plus 1 is continuous function. Okay. Thank you, students.